1 minus x squared times y prime plus x y is equal to 2x. And you have the initial condition y of 0 is equal to 1. So we begin, sorry, I have to forget to do you see the screen now? So we continue. We will use our second method, then we go back to the first method. So actually this is a first order differential equation. We divide by 1 minus x squared. So by dividing, so we divide by 1 minus x squared, we get y prime plus x over 1 minus x squared y is equal to 2x over 1 minus x squared. So this part is qx and this part is p of x. So we continue. The first thing to consider is to put y is equal to v times u. This implies that y prime is equal to u prime times v plus v prime times u. Now we substitute into our function. So we get u prime times v plus u times v prime plus x over 1 minus x squared, and all of this times u times v is equal to 2x over 1 minus x squared. Now you factor out the function u, so you get here v prime and this guy here plus x over 1 minus x squared v plus the remaining is this guy, the other guy is v times u prime is equal to 2x over 1 minus x squared. Next, what you should do is take this equal to 0. So v prime plus x over 1 minus x squared, v is equal to 0. We solve this differential equation, which is separable. This implies that v prime is equal to minus x over 1 minus x squared times v. Now you divide by v. Remember that this is dv over dx. So what you get is dv over v is equal to minus x over 1 minus x squared dx. Next, we take we integrate the both sides. You get here the integral of this part minus this integral. What you get is ln of v is equal to here we multiply and divide by 2. So we get 1 over 2 the integral of minus 2x over 1 minus x squared dx. This is actually in the form of a function u over u. Okay, so the integral, the derivative of 1 minus x squared is actually minus 2 over x. So this is actually equal to ln 1 minus x squared. Okay, so this is the solution plus some constant c. Now you take the x by exponentiation. You will get x is equal to the exponential of this part. What you get is this 1 over 2. You may put it here. So, and you take the exponential, you will get the square root of 1 minus x squared. And remember, the exponential of the plus, we have here a function k, a constant k. Now we substitute back. Is there any question before I continue to the other step? Is this very clear to you? How do we get that k? So here, when you take the exponential on both sides, you get exponential ln v is equal to exponential 1 half ln 1 minus x squared plus a constant c. And remember, this is equal to 1 over 2 ln 1 minus x squared times exponential c. This is k. Okay? So I will continue. The square root is simply when you have 1 minus x squared to the power 1 over 2, which is the square root of 1 minus x squared. Next, when you substitute v into this equation here, when you substitute v here, this part goes to 0. What remains is this part. V times u prime is equal to 2x over 1 minus x squared. So here we have v times u prime is equal to 2x over 1 minus x squared. Yeah. So let's solve this equation. Remember that v is equal to k times 1 minus x squared. So when you substitute this, you will simply need one solution. So you take k is equal to 1. So you have u du over dx is equal to 2x over 1 minus x squared, and this is divided by v, which is 1 over the square root of 1 minus x squared. Now what you get is du, yes, du is equal to 2x over 1 minus x squared to the power, so this is to the power 1 and this square root is the power 1 half. When you add them together, they become 3 over 2 dx. Now you take the integral on both sides. remember that du is actually, the integral of du is actually the function u. And you have to add a constant when you take the integral. And remember that you could here do a change of variable. Okay, so put t is equal simply to x squared. So this gives you that dt is simply the derivative of x, which is 2x times dx. And sorry, yes, is there any question? So you substitute what you get. This here becomes dt over 1 minus t to the power 3 over 2. And it is actually better to take t is equal to minus x squared. So you have here minus 2x, and this becomes here plus. Okay, and here you have minus 1, and you should multiply outside by minus 1. You know why I did this? Because I have minus here and I didn't want to disturb you. So sorry. So when you take this, it will become, so this is the power n. When you take the integration, what you get? So you have minus 1 times, this actually is the integral of 1 plus t to the power minus 3 over 2 dt, which is equal to minus 1 here times 1 plus t to the power minus 3 over 2 plus 1 over minus 3 plus 2 plus 1, which is equal to minus 1 times 1 plus t to the power, when you add 1, so it becomes minus 1 over 2 over minus 1 over 2. So this will go with this one, and you will have 2 times 1 over the square root of 1 plus t. Now you substitute back the real value of t. You will get it is equal to 2 times 1 over the square root of 1 minus x squared. All of this is the function u. Okay, now we continue. So when you take this, the final, remember that you should have a constant c here. So now I will continue. U is equal to u times v. So v is equal to the square root of 1 minus x squared, 1 minus x squared, times now the function u, which is 2 times 1 over the square root of 1 minus x squared plus a constant c. When you distribute, you will find at the end that this times this will cancel out. You get 2 plus a constant c times the square root of 1 minus x squared. And this is the final solution. So y is equal to 2 plus c the square root of 1 minus x squared. Now let's find the particular solution. The particular solution when x is equal to 0, y is equal to 1. That is, y of 0 is equal to 1. Substitute in this, what you get is 1 is equal to 2 plus c times the square root of 1 minus 0 squared. And this will give you that c is, this is actually equals to 1. So you take 2 to the other side, it becomes 1 minus 2. So it is minus 1. And this is the particular solution. Solution is y is equal to 2 minus the square root of 1 minus x squared. Okay? So, is there any question before passing to the second one? Why did I? Ah, yes. I substituted by 1 because we need only one solution. We need only one solution that make this part equal to 0. Remember this part. We need v to, when you substitute v, get this part is equal to 0. When we solve for v, we have many functions that depends on a constant k. We need only one solution. The easiest one is to take k equals 1. So to simplify calculations. Okay, and any value of k will work here. Is that answer the question? Thank you. So now we move to, we apply the next, the method of integrating factor. Remember the solution by the integrating factor. So method of the integrating factor. So we have the equation is like this. Y prime is y prime plus x over 1 plus x over 1 minus x squared u is equal to 2x over 1 minus x squared. Okay? So px here is equal to, this is px and this is qx. Okay? Now we calculate the integrating factor. First of all, the integrating factor u is actually exponential the integral of px. So you calculate the integral of px dx, which is this part, the integral of x over 1 minus x squared dx. And this is actually very easy to compute. You simply, I will use the ways we used to do in classroom. I will not go and simplify it and take another change of variable. So this is actually equals to dx squared over 2, okay, over 1 minus x squared. And I get this 2 here, so I have 1 over 2, the integral, and I multiply by minus 1. I multiply here minus 1, I take dx squared 1 minus x squared. And since the derivative of 1 is 0, I add also 1 here. And this become like this. Now the integral of this is minus 1 over 2. And this is ln of 1 minus x squared. Okay? Now ux becomes, this is actually equals to ln of 1 over the square root of 1 minus x squared. Okay, you take this here, and minus 1 becomes the inverse of the fraction, and 1/2 is the square root. So ux, the integrating factor, becomes exponential ln this part here, which is actually 1 over the square root of 1 minus x squared, or simply 1 minus x squared to the power minus 1/2. Okay? So next, this is the integrating factor, u. Now we multiply by and integrate. We multiply by the integrating factor. So when multiplying by u, remember we have u prime plus p of u is equal to q. And when you multiply all of this by the integrating factor, it becomes u times u prime plus u times p times y times q times u. And actually this part, this u times p is actually u prime, the integrating factor u prime. So all of this is equal to the derivative of the integrating factor times the solution y, which is equal to this part. Okay? Now you integrate both sides. What you get? So let's integrate. So you have, so this is equal to, this is actually dx of, what is the integrating factor? It is 1 over the square root of 1 minus x squared. And this is y. You put here y is equal to, this is the integrating factor. It is 1 over the square root of 1 minus x squared times the value of q that we saw. This is the value of q. 2x over 1 minus x squared. 2x over 1 minus x squared. This is actually 2x times 1 minus x squared to the power. So you add this together, minus 3 over 2. Okay? Now you take the integral over you could simply take, or this is actually equals to 2x over 1 minus x squared to the power 3 over 2. Now we integrate both sides with respect to x. So when integrating, you take the integral of this part and you take the integral of this part. What you get is, remember here, this we take this dx to the other side. What you get is that y over the square root of 1 minus x squared is equal to this integral 1 minus x squared to the power 3 over 2. We do a change of variables dx. So here when you take u as the 1 minus x squared, so du becomes minus 2x dx. You substitute into the equation, you will find that it is actually equals to du over u to the power 3 over 2. And this is actually equals to 2 over the square root of 1 minus x squared after the recalculations and substitution back. So now you will have plus a constant c. So you have here y over the square root of 1 minus x squared. Now you multiply both sides by the square root of 1 minus u square x squared. You will get that u is equal to 2 plus c 1 minus x squared, which is very easy and does not take much time as the first method. So I advise you to use the method of integrating factor rather than the method of taking u, y as the multiplication of two functions u and v. Okay? Is there any questions before going to the next problem? So we move on now. So we have problem number 2, exercise 3, problem 2. So the equation that we are trying to solve right now is x times u prime. X times u prime is equal to u plus x squared sine x. So the solution is we have x times y prime is equal to y plus x squared sine x. And you have the initial condition u of is equal to u of pi, y of pi is equal to 0. So I didn't do any mistakes, I continue. So now we use the method of integrating factor because it is very easy to, it is very quick with respect to the other method. So now we divide by x, we get that y prime is equal to y times 1 over x plus x sine x, and when taking y to the other side we have y prime minus 1 over x times y is equal to x sine x, and this is px and this is qx. So now we use the method of integrating factor. So the integrating factor u is equal to exponential px. So this is actually imply that the integral of px dx is actually the integral of minus 1 over x dx, which is minus ln of x, which is equal to 1 ln 1 over x. Now this implies that the integrating factor y is equal to, when taking the exponential, 1 over x. Okay, now you multiply by the integrating factor. So by multiplication by the integrating factor, we get what we get, that the derivative of u times the integrating factor 1 over x is equal to the integrating factor times q, which is 1 over x times what is the value of q? X sine x. X sine x. So x will cancel with x, 1 over x, and the final answer is sine x. So when taking the integral on both sides, you will have that sorry, so now you take the you multiply by the x and take the integral. So when you take the integral, you will have that u times 1 over x is equal to the integral of sine x dx. And this is actually equals to, what is the integral of sine x? It is minus cosine x plus a constant c. Now you multiply both sides by x, you will get the final answer is minus x cosine x plus c times x. And this is the general solution. Okay? Minus x cos x plus cx. So it is very easy and very quick with respect to the comparing with the first method. Now you have the initial condition is y of pi is equal to 0. So you substitute, you have 0 is equal to minus pi cos pi plus c pi is equal to 0. So this is minus 1, so you will have 0 pi plus c pi is equal to 0. So this implies that c is equal to minus 1. When you substitute, you will get the particular solution is the following, is y is equal to minus x cos x minus x. So it is minus x 1 plus cos x. Okay, so this is the final solution of problem number 2. Is there any questions before going to problem 3? So I move to the next problem. problem 3. So we have problem 3. The next equation is y prime is equal plus 2x minus 1 plus 2x minus 1 over 2x times x minus 1 y, this is multiplied by y, is equal to the square root of x times x minus 1. So let's do this with the same way of the integrating factor. So let's do this. Notice that this is px and this is qx. So in order to calculate the integrating factor dx, we need to make p into into partial fractions. That is, this is 2x minus 1 over 2x times x minus 1. It is equal to a over x plus some constant b over x minus 1. And when you compute a and b, you will find finally that a is equal to 1/2 and b is equal to 1/2. This leads to a is equal to 1/2 and b is equal to 1/2. I didn't write all the calculations because you know how to find a and b. You add and simplify simply, and you do the identification with 2 minus 1, 2x minus 1, you get a and b. Now you calculate, so so you have the integral of p times x would be so it is the integral of 1 over 2 times 1 over x plus 1 over 2 times 1 over x minus 1 dx, and this is actually equals to 2 times ln x plus 1 over 2 times ln x minus 1. And you will factor 1 over 2 and add the ln together. You will find the final answer is ln x times x minus 1, like this. Now, so the integrating factor would be, so this leads that u, the integrating factor, it is the square root of x times x minus 1. And you know why. You take this 1/2 here, and then you take the exponential, and 1/2 is the square root of x times x minus 1. Now you multiply by the integrating factor. What you get is, by multiplication with by the integrating factor, you will get that dx over dx is equal to the derivative of the integrating factor times y, which is equal to u times qx. So how to do this? You have d over dx times the square root of x times x minus 1 times y is equal to the square root of x times x minus 1 times q. What is the value of q? It is the square root of x times x minus 1. The square root of x times x minus 1. So indeed this is equal to x times x minus 1. So when you take the integral on both sides, you will get this x minus 1 times y is equal to the integral of this guy. Okay? You compute the integral, so this integral is equal to x over 2 minus, it is x to the power 3 over 3 minus x to the power 2 over 2 plus some constant c. And next you will divide by 1 the integrating factor. So this is x times x minus 1 times y. So the final answer that we are looking for is y is equal to 1 over the square root of x times x minus 1 times x to the power 3 over 3 minus x squared over 2 plus a constant c. So this is the final answer. Is there any questions? We need to continue the and solve problem 4 since it is very it does not take too much time. Do you have a problem? Do I continue or stop here? So Sabrina says we must stop here. Is there any others that want to continue? So continue the other exercises and we continue next Tuesday the other problems, and I may have I should tell you that you will have a test on Wednesday at 8 o'clock, the two groups together in Amphi number 10. Okay? So, thank you for assisting. Until next time. Also, you will find this, I have recorded this meeting. You will find it in my YouTube channel that I have, and you will find the link in the classroom. Thank you.